So how do we find the slope of a line again? Well, back to grade 9, which is what we talked about in the first activity, slope of a secant. In order to find a slope, we need 2 points. I can pick this one here, and it's going to be 0 and 3. And I can pick another point, let's say this point right here, and it's 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 and 10. So as long as you have 2 points, you said, well, it's easy. This is grade 9 material. I have no problem with it. I can just sub into the formula and I can find the slope as long as I have 2 points, right? If I have 2 points, I can sub into the formula easily and I can get the slope. So in this case, the slope is 7 over 5. 5 units to the right, 7 units up to go from one point to another. And that seems to be easy. Then how come mathematicians have struggled finding the slope of tangent for thousands of years? The idea of calculus is actually relatively new. When we talk about algebra, when we talk about trigonometry, right, that has been there like thousands of years. But calculus, on the other hand, are only a few hundred years of history. Then why has so many mathematicians struggled finding the slope of the tangent? Well, the problem is, by definition, in order to find the slope, you would need 2 points. When you look at a slope of a tangent, we really only have one single point. Many times when you're given a graph and you say, I want to find the slope of tangent at this point, point P, we only have 1 point. And we don't know how to find the slope when you only have 1 point. Some people say, well, can I just find another dot on this tangent line? Well, the answer is no, because this tangent line is not really accurate, right? If I actually have a magnifying glass and I can zoom in a million times, you can see this tangent line here is actually touching the graph at many, many, many points, right? Because if this line is tilted a little bit to the left, a little bit to the right, well, then this point is not really a point on the tangent. So all those dots on this line is not reliable. Like we can't be 100% sure they are actually dots on the tangent. I can't even assure this line is actually the tangent, right? I just randomly draw a line and say it touches that dot. I don't know that's actually the case. So what we need is we can only rely on this one dot, and we cannot rely on any other point on this tangent line. And that's why scientists, mathematicians in the past have given up hope in finding the slope of the tangent algebraically, because they only have 1 point. And the slope formula requires us to have 2 points. Now, where does the idea of calculus come from? The idea of calculus comes from this idea of estimation. It's like, well, I can't find the answer with one single point, but I can guess roughly what it is. You said, well, what do you mean by guess? Well, here's what I meant. Let's say you have another dot on this graph, and I call that Q. And I find the slope of the secant, right? Remember we say secant? This is slope of a secant, not the slope of tangent. And I say this slope of secant is an estimation of the slope of the tangent. Okay. Now, I didn't say it's a good estimation. I just say that it's an estimation, right? And when we're talking about estimation, it could be quite far away from the true answer. And I know this tangent is definitely, this secant is definitely not the same thing as the slope of tangent right there. But what if I go a little closer, right? Now, let me first of all write the slope of the secant out. If I call point P A then the function value would be f at a. If point Q is b, then this is f at b. So the slope of secant would be f at b minus f at a over b minus a, right? Everybody's okay with that? Because that's really just the slope of a line between 2 points, right? That's not a problem. And this is my estimation. Now, what if I bring this second point Q a little closer? Let's say I put it here. Oh, I want to use red because blue on blue, you can't really see. And now I have another estimation, which is now between those two dots. And let me make this second line maybe red so that it's easier for you to see. Now, what I have here is I have another estimation, and I'm going to call this guy Q2 and make this guy Q1. Now, Q2 is still not the right answer, but it's a better estimation than Q1. And if I can get closer and closer and closer and closer to point P, the slope of secant becomes a better and a progressively better and better estimation for the answer. Now, I'm still not getting the answer, but I'm getting a better estimate of the answer. So as you can see here, what we're doing is still finding a slope of a secant between 2 points. It's just that second point is getting closer and closer and closer and closer and closer to point P, that the slope of secant becomes a better estimate of the slope of the tangent. And we introduced this idea of getting better and better by showing you this example. Now, for time, I wrote some of it out already. So here, I have this function, f at x equal x squared. So I have a parabola here. And I have a point at 3 and 9, and want to find the slope of the tangent at that point. Okay, so my point P is at 3, and my point Q is a little over to the right, 3.5. And I'm going to make the second point progressively closer to 3 and see what happens to the slope of the secant. So if you have a calculator, you can take your calculator and do it with me, so that it's not just me writing it, right? You want to convince yourself that this is actually what's happening. So the function is x squared. So 3.5 squared minus 3 squared would be in the numerator. And then denominator will be 3.5 minus 3, and you're going to get 6.5. So this first slope of secant is 6.5. That's an estimation of the slope. Now we're going to move a little closer. 3.1 squared minus 3 squared divided by 3.1 minus 3. So that's 0.1. And now I'm getting 6.1. I'm going to bring it even closer, 3.01. So 3.01 squared minus 3 squared divided by 0.01, and I'm getting 6.01. Right, one more, 3.001. I'm getting really close now. And I get 6.001. So I am finding the slope of the secant between point P and point Q, and the Q value is getting closer and closer and closer to point P. And the slope of secant goes from 6.5 to 6.1 to 6.01 to 6.001. So this is what happened as I go from the right. Now, this answer that you get, it's always going to be smaller. It's always going to be smaller than the slope of the tangent. It's always gentler, right? A little flatter. Now, if you go from the other side, what you're going to get is you're going to get a bunch of tangent, a slope of secants that's going to be a little higher. So let's see what happens if I go from the other side. So I'm going from 2.5 to 2.9 to 2.99, and I'm going to go through the same calculations again to see what the estimation is like if I go from the left. So here, point P is actually bigger than point Q because I'm going from the left. So I'm going to switch the order around a little bit. 3 squared minus 2.5 squared divided by 0.5. And I get 5.5 this time. Okay. What if you put in 2.9? You're going to get 5.9. What if you get 2.99? Well, you actually get 5.99. So if I put both of them on this next chart, this goes from 5.5 to 5.9 to 5.99. On the other side, it goes from 6.5, 6.1, 6.01, 6.001. Well, what do you think they're both converged towards? It looks like, exactly, right? It looks like they both converge toward this magic number of 6. Now, I didn't actually find the slope of tangent. I've been only finding the slope of secant from the left and the slope of secant from the right, but I can use that to guess that the slope of tangent is going to be at 6. As I converge from the left and converge to the right, they all converge towards the same number. So even though I'm just estimating, I didn't actually know how to find the slope of tangent, but as I get closer from the left and closer from the right, it seems like they're pointing me towards the same value, and that value is 6. So what we can do then is recall the slope of the tangent at a point P is what we call this big term, this new idea in math called the limiting slope. The limiting slope of the secants of PQs as point Q slides along the curve towards P. In other words, the slope of the tangent is said to be the limit of the slope of the secants as Q approaches along P, towards P along the curve. So another way to say Q is we can say Q is a little bit more than point P, a little bit to the left, a little bit to the right. So if point P is A and F at A, the X and the Y values, and I call them X1, Y1. And this point Q is a point that's so close to point P, just a little bit bigger, right? So this is the X value of point Q, and that's the Y value of point Q. Then this slope of secant, which we all been doing, is going to equal to Y2 minus Y1 over X2 minus X1. And if you look at the denominator, what can you do when you have A plus H minus A? Well, the two A's is going to cancel. So what's in the denominator is just this H, which is like a little bit more than A, right? And the slope of secant is when that little bit becomes 0, meaning it's not equal to 0 because we cannot divide by 0. That's not possible mathematically. We are saying, we're introduced this symbol, and we're saying the H value, that little bit, is going towards 0. It's getting closer and closer and closer to 0, but not 0, right? And what's that little bit? The first case, the little bit was 0.5, and then was 0.1, and then was 0.01, and then was 0.001, right? And as that little bit gets smaller and smaller, the answer, the slope of the secant, gets closer and closer to the slope of the tangent. And we say as this value getting so small that it's like 0, then the slope of the secant is like the slope of the tangent. So in everyday English, that's what it means. And we introduce the idea of the limit. So we have to write it like this. LIM stands for the limit. So the limit as h approach to 0. This is really the slope of secant. F at a plus h minus f at a divided by x2 minus x1, which is just h. So this is referred to the slope of the tangent in the format of a limit. So when we try to find a slope of tangent, we need to use this particular formula. Limit as h approach to 0, f at a plus h minus f at a over h. And this is the formula we need to use to find slope of a tangent. Some students say, can I just do this every single time? Well, it's not really recommended that you do this every single time, even though this will work, because this is actually what happens in a limit. But this is too tedious in terms of there's a lot of work. And how many is enough, right? How do I know this is actually 6 and not 6.0000001? Like, it's hard to say when you're talking about converging from the left and converging from the right. So it is recommended, and we need to use this definition of the slope of the tangent whenever you're asked to find the slope of the tangent in this particular unit. Now, some students can say, well, how do I use it? Exactly, because in unit activity 2 here is a lot of theory. It explains to you what the slope of tangent is. It's not a lot of questions where we can ask. How we ask the questions are in the next one. But let me show you how to do this one that we just did, that we did with the estimation. How we can actually solve it using the equation, which is this guy here. Okay. Now, let me talk a little bit about this idea of a function, right? You guys should have learned functions back in grade 11, but some students are not very familiar with it. So let me just again show you what a function notation means. So if f at x equals x squared, f at 1 means you sub 1 in for x, right? F at k means you get sub k in for x. So basically, whatever x is, you substitute this in for x. So sometimes I joke in class and say, well, if you have f at an apple, then this becomes apple square. You can tell I don't teach art because my art is not very great. And if I put Rice Krispie in there, then you get a Rice Krispie square. Makes me a little hungry that I want to eat now. So if I have f at a, then you're going to get a squared. If I have f at a plus h, you're going to get a plus h squared. Whatever x is, you replace it with what's inside the bracket. So here, I am trying to use this formula to figure out the slope of the tangent at x equals to 3. So a value, which is the x value, is equal to 3. F at 3, that's 9. What's f at 8 or 3 plus h? Well, that's going to equal to 3 plus h squared. So this is going to equal to the limit, and I always have to copy this down. If you don't, that's a formatting mistake. You will lose marks. So f at a plus h becomes f at 3 plus h minus f at 3 over 3 plus h minus 3, which is just h, right? Slope of secant, a point a little bit bigger than 3 minus 3. That's really what this means, right? Now, what's f at 3? You put 3 there, 3 squares 9. What's f at 3 plus h? Well, that's this guy. And if I expand it, I'm going to get 9 plus 6h plus h squared, which I need to put in here. I'm going to just use a different color. So you see where I get this from. What's so special is, and you have to keep this in mind, anything that does not have an h or a h will be canceled out. See, the 9 here does not have a letter H. Anything that does not have an H will always cancel out. If it didn't cancel out, you probably make a mistake somewhere. It's very important that everything that does not contain the letter H will cancel out, because what's next step is you're going to factor out a letter H from what's remaining. So here I factor out the H, and I'm going to get 6 plus H. See, 6 plus H, because I factor out a common factor of H. And now if I divide by an H, those two will cancel. H divided by H is 1. Again, H is not 0. H is very small. It's like 0.1 billion zeros and a 1. So I can actually cancel them. I'm not canceling 0. I'm canceling something that's very small, right? Now, the final answer is this. The slope of the tangent of this function at x equals to 3 is the limiting slope of the secant of 6 plus h. When h gets really, really, really small, like 0, then this value is converging towards 6, because the value of h is going to be getting smaller and smaller and smaller. It's going to be like 0. Well, if this is like 0, then the whole thing is going to be getting closer and closer and closer to 6. So 6 is your slope of the tangent. And this is what we call first principles. You're asked to find the slope of tangent from first principles. That means you must use this formula and go through it algebraically, not by estimation. Okay, let me try another example. Here's another function. Negative x squared plus 4x plus 1, which is this parabola right here. And I want to find the slope of the tangent at x equals to 3 right here. So what's the formula? Let's write down the formula. Limit h approach 0, f at a plus h minus f at a divided by, oops, forgot a bracket there, divided by h. What's the value of a? A is 3. So I need to find out what's f at 3 plus h. And I need to know what's f at 3. So I need to substitute that into the equation. So you can do a little bit of work on the side if you want. The function is negative x squared plus 4x plus 1. F at 3 is negative 3 squared plus 4 times 3 plus 1. That's going to be negative 9 plus 12 plus 1, which is equal to 4. So f at 3 is going to equal to 4, right? So equal limit h approach 0, f at 3 plus h minus f at 3 divided by h. Now, what's f at 3 plus h? Again, if you want, you can do this on the side. F at 3 plus h. It's anytime you see x, you put a bracket and you put in what's inside. Okay, so here it's 3 plus h, and that's 3 plus h. So expand and simplify a little bit here. You do require some algebra skills, 9, 6h, h squared, 12, 4h. Make sure you do distributive law. So the negative sign has to be distributed around to all three things as well. So you're going to get final answer of -9 minus 6h minus h squared plus 12 plus 4h plus 1. Simplifying, you're going to get negative h squared minus 2h plus 4. Now, you put this in for f at 3 plus h. You put that in for f at 3, and you can solve for the slope of the tangent. Okay, negative h squared minus 2h plus 4. Minus f at 3, which is 4. Remember, anything that does not contain the value, the letter h, will cancel out. See, they cancel out. And you need to divide by letter h. Factor out the common factor of h. You get negative h minus 2 divided by h. H's cancel. They always cancel. If they don't cancel, something's wrong. You probably make mistakes somewhere. And now, the limiting value, or the answer, is right here, obvious. Limit h approach to 0, negative h minus 2. Now, what happens when h is very small, it's like a 0? Well, then this is 0 minus 2. 0 minus 2 is just negative 2. So the slope of the tangent is negative 2, which is right here. You can tell the slope was negative, right? It's going downwards. So that's the slope of the tangent at this particular point, and it's equal to negative 2. Okay. So that's the first type of function. We call it polynomial function. We do have a couple other types of functions. One is called a rational function, which you should have covered again in the advanced function class. A rational function is when you have a numerator and denominator. And the last type of function we're going to talk about is going to be what we call a square root function. Okay. We do have to go a little bit probably towards 3:15, 3:30 today, because in the beginning of class, we spent about 10-15 minutes to talk about, the course, how it's set up and things like that. Okay. So if you said, oh, I thought the class is only between 2 to 3, well, minimum is an hour is what e-learning is asking us to do. Most of the time is going to be a bit more than an hour, right? Hour and about hour and a half. So we have 2 more examples. Okay, so here's another function. This is called a rational function. You're going to have a numerator and a denominator, but the steps are similar. You ask to find the slope of a tangent. You're given a point. So you're going to say, let me set up. Slope of tangent is going to equal to f at a plus h minus f at a over h. Now, if you write that on a test, you're going to lose a mark. What's missing? Right? People are still here. What's missing? If I write something like this on a test, I'm going to lose a mark. Oh, good. Some of you are telling me, yeah, right? Make sure you put this, right? This is important because that's new. This is what we're learning. You have to put in the limit. Without the limits, right? People say, oh, I get all of my work right. How come you're not giving me perfect? Well, your notation is not right. Without the limit, this doesn't make sense, right? This is just the slope of a secant. This is not slope tangent, right? It's fundamentally wrong if you don't put in the limits, because you're just finding the slope of a secant. You're not finding the slope of a tangent. The slope of tangent is the fact that the value of the h, that little bit, is getting smaller and smaller and smaller. It's almost like 0. And that's why we can say this slope of secant is equal to the slope of tangent. So this is very important. Make sure you keep it there every single step until you reach to the end of the question. Okay, so here my a value was 2. So I need to find f at 2. And I need to find f at 2 plus h. Now what's f at 2? We're going to put 2 into the function. 3 times 2 plus 6 divided by 2. This is 12 divided by 2, which is 6. If you get 2 plus h into the function, this is 3 times 2 plus h plus 6 divided by 2 plus h. Again, anytime you see the letter x, you have to replace it with what's inside the bracket. Maybe I'll use this. See the x here? I guess you can still see the x there. So you need to replace this with the x. You need to replace that with the x. Just like what we did here. It's just, that's a 2. But here it's a 2 plus h. So this one's going to be a little trickier because you're going to get 12 plus h over 2 plus h, right? 12 plus 3h. You see, when I try to rush a little bit, I make mistakes too. So you got to be careful. Okay, distributive law, 6, 3h, 6 and 6, 12, 12 plus 3h over 2 plus h. So this becomes limit h approach to 0, 12 plus 3h, sorry, my writing board didn't register well there, plus 3h over 2 plus h minus 6 over h. And we have many students struggle with fractions, right? This is like, you know, it's like a big gap, a big void in their life with fractions. I have students every year come to me and say, I don't know anything about fractions. Don't ever give me a fraction question, you know, ever on the test. I said, well, that's not how it works in real life, right? You can't go to your boss and say, you know what, yeah, only give me whole numbers, right? Do not give me any fractions in life, right? I cannot deal with it. So I can't give you that promise. A rational function by default is a fraction. That's called rational function. Now, how do we do fractions? So if you have something like this, right, how do you subtract them? Well, the key with fractions is common denominator. You can only add and subtract when they have the same common denominator. So here you will have to make this a common denominator. So 1/3 minus 15 over 3, so that they are the same denominator, and you can subtract the top. So here, the top here, what I need to do is I need to make them a common denominator. So limit h approach to 0. I'll leave the h at the bottom. I'm not dealing with that yet. This is 12 plus 3h over 2 plus h minus 6. 6 what? Well, I have to make them common denominator. So 2 plus h is the denominator. 2 plus h has to be multiplied in there as well. Okay, so now I have a common denominator. I can add and subtract the numerator. Okay, so let me expand and simplify a little bit. Right? Generally, because this is a grade 12 class, I don't really need to go show every single step, or I shouldn't have to show every single step. So here, if I expand, this is going to be minus 12 minus 6h, right? Distributive law. So 12 minus 12, great, canceled out. You have 3h minus 6h, you're going to left with negative 3h in the numerator. Okay, so common denominator and add and subtract the numerators here. So it's 12 plus 3h minus 6 times that, which is minus 12 minus 6h. Okay. Now you see the h at the bottom and the h at top cancel. So again, they have to cancel. If you don't cancel, you make a mistake somewhere. Limit h approach to 0, negative 3 over 2 plus h. Now what happens when this h value is so small, it's like 0? Well, then the slope of the tangent is going to be negative 3 over 2. anytime you have a rational function, right? Fractions, pay attention to common denominator. That's usually the most common mistake. Students are having trouble adding and subtracting this part, right? They try to cancel here. Well, you can't cancel them. This is a subtraction. You have to make the whole numerator and cancel with the denominator. So this part, you have to do common denominator. You have to make them the same denominator before you can add and subtract the numerator, right? And that's really the key for any rational functions. Anything that contains fractions, remind yourself that you need to do common denominator. Okay, one last example for today is the last type of function. The last type of function is a square root function. Now, what you're asked to do is still the same. You're asked to find the slope of the tangent. You will be given a point. So you're going to do exact same setup. Limit h approach to 0, f at a plus h minus f at a divided by h. This time, a is 9. So I need to find f at 9. And I need to find, that's a 9, sorry, f at 9 plus h. The function is square root of x. So square root of 9, well, that's good. That's 3. Here, you're going to get square root of 9 plus h, which we can't really simplify. Okay, so let's put it in here first. Equal to the limit h approach 0, square root of 9 plus h minus 3 over h. Anytime you see square root functions, you have to go back to something that you learned in grade 11. We call this conjugate. The idea of a plus b multiplied by a minus b, like a difference of square, what you're going to get is you're going to get a square minus b square. What's special is the square, because whenever you square a square root, you cancel the square root. So what we have here is in the format of what we call a minus b. You see, something minus something else. We call this a minus b. So what you do is you multiply by the conjugate of that, which is a plus b. But you have to do both the numerator and the denominator. A is whatever's in the front. That's square root of 9 plus h. B is whatever at the back. That's a 3. Since this is minus, that's going to be, and I'm going to use different color here, plus. Just copy whatever you have on this side over there, except you switch the sign. If this is a minus, you make that a plus. And then you copy the same thing in a denominator. Some people say, oh, this looks so complicated. It may seem complicated at this point, but then the next step is going to be super easy. Okay? But you have to recognize anytime you see a square root, you have to say, I need to do conjugation. I need to look for the conjugate. A plus b, I have to multiply by a minus b. A minus b, I have to multiply by a plus b. Conjugation. Oops, not there. I need to go for it, not backwards. Okay, so here, I'm going to have this multiplied by that. This multiplied by that. And I'm going to show you on the next slide here why that's super easy. 9 plus h minus 3 times 9 plus h plus 3. This guy is your A. This is your B. This guy is your A. And that's your B. When you have a difference of square like that and you multiply, you're going to get a squared minus b squared. Well, what's a again? Well, a is whatever's in the front. Actually, let me use different color. A is this guy. What's b? B is that guy. What happens when you square the square roots? Well, it simply removes the square roots. And 3 squared is 9. And what do you get when you do 9 plus h minus 9? Everything cancels out. You're left with the letter h. That's it. Your letter with the letter h. That's it. It may seem very complicated initially, right? But when you expand it, a squared minus b squared, all you left was just the letter h. So this part, the numerator, everything multiply, it's the letter h. Why h is important? Well, because I need to cancel with this h, right? I gotta have an h to cancel with it. So limit h approach to 0. I have an h left on top. I have an h at the bottom. And perfect. They just cancel each other out. And what's left is this little part in the denominator. So the answer is that little part in the denominator. So, oops, I don't want that thick. Limit h approaches 0. Those two things cancel. So you have 1 over the square root of 9 plus h plus 3. That's your final answer. Except now that h is so small, it's like 0. Well, if this is 0, then this is square root of 9. Square root 9 is 3. 3 plus 3 is 6. So the final answer is 1 over 6. And this is your slope of the tangent. I see a question on the chat. Let me take a quick peek. How did you get the denominator? What do you mean, this denominator? You have to multiply by 1, right? You can't change the question here. So when you multiply by the conjugate, you have to make sure you have the conjugate in the denominator. Okay, so basically whatever's in the numerator, you copy it down on the denominator. The numerator, you do your difference of square, a squared minus b squared. The denominator, you just copy over. It's just the h at the top and the h at the bottom cancel. So what's left is just this little part. Okay. So for the third learning goal here is you are expected to be able to find the slope of the tangent using this definition of the limits. You are expected to be able to do the 3 different types of functions. First type of function is what we call polynomial function. Obviously, x squared is a simple one. Here, the second example was a little harder, right? A polynomial function, which you learn at the advanced function course, MHF4U. The second kind of function that you should be able to do a slope of tangent is the rational function, where they have a numerator and a denominator. For questions like that, pay attention to common denominator. You have to add and subtract with common denominators, right? A lot of people struggle with the fractions. Be careful with that. The third type of function you're expected to be able to find the slope tangent for is the square root function. So anytime you see a square root in the question, you probably would have to do conjugate. If you have 8 minus b, then you multiply by 8 plus b, where a squared cancels the square root. Okay. And I have a few questions for you to practice. You have a couple polynomial functions here, a couple rational functions here, and a couple square root functions here, where you can do as a practice.